Hello there and welcome to Lower 6th Further Maths A. This is the January mock exam revision sheet 5. Here we're working on the standard complex numbers questions. So the first part is work out the modulus argument form of 2 minus root 3i. So the first thing we would do is, if we're stuck, plot the complex number on an argand diagram. So 2 root 3i will be somewhere down here. 2 minus root 3i. And the first part, the modulus of this complex number, is going to be the distance to the complex number from the origin on the argand diagram. So this here is going to be calculated by doing the Pythagoras Theorem on this triangle here. Now bear in mind that on this side of the triangle, on the right hand side here, the vertical side, or the y component, the distance on that axis is just root 3. You don't include the I when you're doing these calculations. So it's 2 squared plus root 3 squared, and that will equal the square root of 7. So leave it as that, don't work it out as a decimal. Okay, now we need the argument, which is the angle that's formed from the real positive axis down to the line that represents our complex number. So here the argument of z is equal to tan, because we're working with opposite and adjacent, of square root of 3 over 2. However, we've missed one thing off. Now, when it's on the top of the argand diagram, the modulus is positive, and when our argument is on the bottom of the argand diagram, our argument is negative. So it's going to be the negative of tan root 3 over 2, and the answer to that is minus 0.714. Okay, so that's part A done. Part B, given that the modulus of w is 4 and the argument of w is minus 2 pi over 3, find zw. Okay, so what we're going to do here is we're going to give our answers in argument modulus form, and remember a couple of rules. So to find the modulus of zw, we're going to times the modulus of these two complex numbers together. So mod z times mod w. So remember that rule there. And if we want to times our complex numbers together and find the argument of them, then that means that we're going to add our two separate arguments together. So arg z plus arg w. So that's what we need for the first bit, part I. So in argument modulus form, remember this is going to look like r cos theta plus I sine theta. This is what the complex number is going to look like. The r here is going to represent the two complex numbers and moduluses multiplied together. So it's going to be minus 0.74 times minus 2 pi by 3. That's going to give us... Sorry, no, we're not multiplying the arguments, are we? We're multiplying the moduluses. So we're multiplying root 7 and 4. So that would just be 4 root 7. And now inside the argument parts, we're going to add the arguments together, and what we're going to get there is minus 2.81. So minus 2.81. And what we did to get this is we took minus 2 pi by 3 and added it on to minus 0.714. And then it's plus I sine minus 2.81. So that's the complex number for ZW. And we have to remember a few separate other rules for dividing two complex numbers. So for example, the division of two complex numbers can be calculated by the division of the moduluses. And the argument of two complex numbers divided by each other can be calculated by subtracting the argument of one from another. Okay, so still in this sort of form here, it's going to be it's going to be z over w, so it's going to be root 7 over 4, so dividing our two complex numbers here, times by cos. And now what we're going to do is we're going to do arg of z minus 0.714, take away minus 2 pi by 3, the argument of w, and in that we get 1.38, and that'd be plus I sine 1.38 as well. Okay, so that's our answer for z over w, written in argument modulus form, and this here is the answer for zw, written in argument modulus form as well. Okay, great, that's 6 marks.